And over to you, Arin.
All right. My name is Arin Sime. I'm founder and CEO at WebRTC.Ventures. We're going to talk about architecting your WebRTC application for scalability today. With me today is Alberto's not with me today. Alberto couldn't make it, sorry. But we have a longer version of this presentation where he'll say more intelligent things than me that we'll be posting online as well. But we'll talk about a number of different things about architecting WebRTC applications. I notice that while Alberto speaks SIP and telephony, I don't, and most of the work that we do is really video related. So when I say things like CPaaS in this presentation, I'm really thinking about them most particularly in the video context. But you certainly can do audio-only WebRTC applications, and we have a couple slides that I may or may not get to talking about integration with SIP and telephony as well. So you can definitely think broader than that, but know that in my mind, I'm often thinking about video. 10 plus years ago, we were told that WebRTC was going to be simple. There were some jokes made in the panel yesterday about WebRTC being free, question mark. Of course it's not, because there's a lot of work that has to go in to building these things. But the way that it was originally sold to us is as, and is still certainly true in certain use cases, a peer-to-peer way to exchange video and audio and data with nothing in between except for a signaling server to help establish that RTC peer connection. That is a great model for many scenarios. However, there's a lot of other things that you do have to consider in most production applications, and absolutely if you're doing any form of scaling of your application. And those include stun and turn servers to help establish those peer-to-peer connections, but also many other features that you may be including, things like recording and broadcasting, larger group chats, all really require you to have an architecture more complicated than this. So the first part of the presentation, what I'll talk about are the kind of 4 ways we think about that you're going to build a video application, 4 different key architectural choices that you need to make. Any of these could be scaled, but they do affect how you scale and the cost of that scaling. So before you even consider maybe how to scale, this is sort of the first architectural choice that you're making. And I'll go through each in turn. The first is to build directly to the WebRTC standard, the original way to do it. However, this can be quite complicated. In most situations, I don't think people do this anymore. It's very unusual in the work that we do at WebRTC.Ventures, where, by the way, as I think I forgot to say at the beginning, we do services. We are live video integration experts for clients building web and mobile applications. So I don't have a product to sell, but we can help you build your product. So that's kind of our role in the ecosystem. And generally speaking, this is not the way that we're doing it anymore. In addition to considering the stun and turn servers, you may have to consider things like video codecs. You've always got to consider your application signaling, but you're going to have to maybe deal with browser and mobile support and lots of other things that libraries around the WebRTC standard will do for you, which is why that's generally not as common now. The second option I'll mention, and these are kind of in no particular order, is unbundling WebRTC. So I guess to say this isn't really WebRTC, but this is what Tim mentioned in the panel yesterday and is definitely talked about more often now. This also is not something we see a lot of yet, but for certain use cases could be very interesting. And the idea here is that instead of building to the WebRTC standard, you're actually using WebAssembly and building in your own way of doing web codecs and web transport. You have more flexibility in that. So in scenarios where scaling to you means, for example, that you may want to do a very particular type of encoding of video or bias towards certain video streams over others, it's something unique to your use case. This may be a more powerful but complicated way for you to look at building your application that will give you some scaling benefits. The third option is open source media servers. And there are many different choices to look at here. This is generally going to, think of this kind of as your abstraction around a lot of WebRTC for you. It's probably going to handle stun and turn for establishing the RTC peer connections. It's going to handle part or all of the signaling for you. It's going to handle browser compatibility, video codecs. It may be an SFU or an MCU. I'll talk about those in a moment if you're not familiar with those. It may have some scaling capabilities built into it. It may also have other features built into it. But as with most open source projects, the idea here is you have a tremendous amount of capability that someone else has built that you're able to leverage. However, you are still managing from a scaling perspective, and particularly, you still have to think about all aspects of the infrastructure, the DevOps, the hosting around that, and that's going to be where you're going to spend a lot of time from a scaling perspective with any open source media server choice. And there are a lot of great choices to look at. On the open source side, these are a few. And then the fourth general architectural choice is CPaaS. Again, when I talk about a communication platform as a service, I'm thinking primarily around the video side, but many of them have telephony features built in as well, SMS, etc. The nice thing about this is they're going to handle all the hard parts of WebRTC for you. They're going to handle a lot of the scaling for you as well because they already have the global network of servers set up that you don't have to deal with. They're going to handle stun and turn for you, so that it's really a lot built into this. But of course, that comes with a price. You're going to pay a higher transactional cost. Excuse me. May also have a lot of features built into it that are themselves hard to scale. For instance, if you need recording, the fastest way to build a video application with recording built into it is certainly going to be a CPaaS-based solution, but that's also going to increase the cost of it. And you're also stuck with recording the way that they envision doing recording. And some providers put all the videos together into one recording file, which is nice. You don't have to sync them up, but if you don't like the layout that they put into that recording, you're stuck, right? So you're stuck with however they envisioned building that feature. And there are a lot of great providers here as well to use. We've worked with all of these. And so really this first part of the architecture is very much about different trade-offs that you want to make. So you have to think first before you're scaling your application. It's not just, does this scale well or not? It's, well, what does that mean to you? What are the different things that you care about? And generally speaking, when we're talking, especially as a services firm, talking with our clients, they care very much about what we're going to charge them. We're generally that upfront cost for them, and we're not necessarily cheap. So that's something they're very concerned about. So for instance, if they want to reduce the upfront costs with us, it's better for them if we build with a CPaaS something that maybe we can get to market faster, as opposed to, say, an unbundled application or building directly to the standard where it's going to take more work on our part and therefore cost them more, right? However, the upfront cost might be worth it if you really know you're going to scale very large and you're much more worried about the ongoing transactional cost that CPaaS is going to bring you. And so you want to go straight to an open source media server solution where you can control all the infrastructure, etc. So if the ongoing cost is more important to you. There's also the technical difficulty to consider, the features that may be included to consider. And so there's a whole range of choices to make here. And then I added on a couple things too, as I was thinking yesterday, listening to other presentations, because there's also the consideration of, do you or your investors care about intellectual property? I think Alan mentioned someone, I don't remember who, but who made a company that made a very good exit on his list, being built on Twilio the whole way. Well, that's great that they were able to do that. Obviously, they didn't have the intellectual property around that part of their core service, and in that case, that worked out great for them. In other cases, your venture capitalists are going to want you to own more of that. Maybe that drives you towards unbundle, for example. But also an important thing to consider here is strongly encourage you, especially for a scaling perspective, to build your application with your initial choice, but the flexibility to move to something else in the future. So the more that you can abstract out that choice, because we certainly regularly talk to people who say, I made this choice within this matrix or with this particular provider, I'm no longer happy with that choice. It's not easy or cheap to have us rebuild that for them in a different solution. If you think about that up front, think about that your first choice doesn't necessarily have to be your long choice that may affect how you build your application. So when we go from peer-to-peer, a peer-to-peer connection of 2 people to say only 8, Obviously, you know, you're familiar with how much more complex that makes it. That's why we do need these different media servers. And I'll breeze through a few slides around this and then keep my presentation short. The MCU, SFU is a primary media server choice that you need to make. SFU is the much more common choice to make now. However, it does push more of the processing burden onto the clients, to the people connecting to it, to your end users. Generally speaking, that's okay. In most applications, MCUs are going to take more of that burden on in the processor themselves, and we skip it ahead here, it'll make more sense why. An MCU will mix all of the audio and video on the server and then push a single stream of that combined video out to users. Whereas an SFU, each participant pushes up one copy of their video and audio, and they get back one stream for every other participant on the call that they're in. So that's why there's more processing power required on the client side with an SFU. But that allows for some additional features that most people like in modern applications. For example, any meeting tool that you've been in where you as the user were able to change the layout during the meeting pretty much guarantees you are on an SFU, because you have those individual client streams, and on the JavaScript side they can be laid out in a different configuration. An MCU is not going to allow that. Also, people talk about doing full end-to-end encryption. Pretty much have to be on an SFU in that case, because the SFU is not really manipulating any of those video streams, so it doesn't have to decrypt them. It can just pass them along to everybody, whereas an MCU is going to need to decrypt those on the server in order to combine them. So, in addition to scaling, security, and things like that. But these also, one of the other reasons an SFU model is going to be more popular is that it does have lower CPU requirements itself, because it's not doing that composing of the video, so that's going to mean you need fewer SFUs to scale as compared to an MCU. So anyways, the basic model here when you're scaling these out is to cascade them. So if a particular SFU can handle a few hundred connections, which might be typical, and you're expecting to have thousands of concurrent viewers, ooh, now we're talking broadcasting. WebRTC wasn't really designed for broadcasting. It was designed for peer-to-peer group video chat, but it's being used in broadcasting scenarios a lot now. So because of the very low latency of WebRTC connections. So now that means we have to have a lot of horizontal scaling of the SFUs built in. If your goal is instead to build large group video chats, and why you would want to talk to 100 people at once, I don't know, but people regularly ask for this sort of thing, right? And they seem to all believe that we can actually process seeing 100 people on the screen, which further boggles my mind, but if they pay for it, we'll build it. But you know, think of, this affects how you scale, and you really need to dig into, well, first of all, you know, question, do you need the 100 people on the screen at once? And what's the scenario? So the scenario I like to think about here is in ed tech. You know, imagine that you're doing an application for remote proctoring of an exam. You have 100 students in the class perhaps, and part of the tooling is to help you ensure that cheating's not happening. You want to be able to look at each student periodically as they take the exam. One way to do that is to have 100 students on the screen, right? But certainly those 100 students don't need to see each other. So that affects how you're going to architect the media servers. Only the instructor needs to see all 100 students. Furthermore, do they need to see all 100 students at once, or can they paginate through pages of the students? If you can paginate through, then each page could be a separate group video chat of a more reasonable number of, say, 20 people or something like that in it, right? So really think through the flow of the application, and that will affect and hopefully reduce the burden of what you need to do in implementing it. And then here's a telephony slide. So this can get, and Alberto, who made this slide, would say that, well, this looks more complex. It's actually much simpler than it really is to build it, and most of you in this room probably know that better than I do personally as well. It's not easy to build that in, but you can most often you're going to use an MCU for the telephony integration part, so that you, for example, if you have a video SIP phone, you can have a composed video stream that's going to that. It's not going to speak well with an SFU probably. But you can still have other participants connected to an SFU, or depending on your business logic, maybe they're connecting to a WebRTC connection over to an MCU rather. And of course, you have to consider are the dial-in people, are they also using audio? Are they only on audio? Most likely. How do you handle all of those connections? Some of the CPaaSs handle this for you, but they definitely do not all handle it the same way. So there's a lot of things to consider here when you're scaling, thinking about integration with other systems like VoIP legacy systems, recording, voicemail, speech transcription, how exactly you want to do multi-party video conferencing support. And then you also, last couple slides here, which I really won't dive into, but I'll encourage you to check out Alberto's discussion of that in the recording more later, talking about handling things as you're horizontally scaling. How do you make sure that you do that in a stateful way that scales well? So for instance, if you have 100 SFUs running in parallel to handle thousands of conversations in parallel, what happens if one of those SFUs falls over, one of your servers falls over, and those people try to reconnect? And you need to get them back to the same room, or only some participants disconnect, but you want to get them back to the same room on the same media server. That implies that you're going to have some orchestration, some state persistence across those servers to handle that, as well as thinking about other things like how are you going to scale it? Most likely connections, but there are other parameters you're going to look at. You're going to do load testing to measure around what is the maximum number that we want to start our auto scaling at, users per room, number of rooms per server, combination thereof. All those will affect how well that individual media server can handle. It's not just I can handle 400 connections at once, because it may be different if those are 400 peer-to-peer, or excuse me, not peer-to-peer, but one-to-one conversations versus 4 100-person conversations. Those are not equivalent load on the server. So all of that needs to be considered as well and handled very carefully, and the only way you're going to handle that is with significant load testing to figure out what those parameters are and then test them. So, and there's other things coming too that'll be in the recorded version, like the AV1 video codec that can help some of this. So anyways, I'll keep it short there. If you have any other questions around this, I'm happy to talk with you about it today, or you can contact us, team at WebRTC.Ventures, and I'm also happy to connect you with Alberto for more SIP talk.
Excellent, thank you so much, Arin.